All right, college algebra. We're looking at rectangular coordinates and graphs in section 2.1 today. All right, now first thing we're looking at x and y intercepts. So when you have a graph, whether this graph is just a line or whether your graph is like a parabola, like this right here, you have important values of intercepts as far as where it crosses the x-axis or where it crosses the y-axis. This is your x-axis going horizontally. This is your y-axis, which goes vertically. Okay, so right here, this is the point that it crosses the y-axis, which is called your y-intercept. This point right here, the point where it crosses the x-axis, is called the x-intercept. So if I just make up some values here, this looks like maybe 1, 2, this looks like -3, 0 is what this value, this point right here is. This is my x-intercept. This one right here, 1, 2, that's +3. So that'd be 0, +3. 0 means I'm not going over any horizontally. 3 means I'm going up 3 vertically. But if you notice on my x-intercept, y is 0. And no matter where you're at on this line, like if I'm right here, if I have another line that goes through there, that would be 5, 0. And see, my y is 0. So a thing to know, your x-intercept, y equals 0. And then for your y-intercept, x always equals 0. So for your y-intercept, for your x-intercept, y is always 0, and for your y-intercept, x is always 0. Same thing on this one. Now if you notice on this one, this graph does not have an x-intercept. It doesn't cross the x-axis. So there is no x-intercept. That happens sometimes. But it does have a y-intercept right there, so that looks like maybe that's 2. So that'd be 0, 2. But if you notice, my x is 0, the y is 2. That's my y-intercept. Okay? So, knowing that, if we look at this question here, number 1, the y-intercept of the graph is what? Okay? Well, the y-intercept is when x is 0. So all I do is I put 0 in for x, and that would tell me what y is. So if I put 0 right here, I've got -4 times 0, which is 0, plus 8 would be 8. Y would have to be 8. So that's my y-intercept. What about this one here? Enter the correct answer. The x-intercept of this graph is what? All right, we're looking for the x-intercept. Okay, so I have 3x plus 2y equals 6. I'm looking for the x-intercept. That means y would have to be 0 then. So if I put a 0 right here for y, I've got 3x plus 2 times 0, which is 0. So I'm not even going to write it. That should equal 6. And so I divide by 3. X would be 2. So that means 2, 0 would be my x-intercept. Okay? Which is what you see right here. What about this one? The graph of this has no x-intercepts. It has no intercepts. Let's find that out. So we got y equals x squared plus 3. All right. Now, if it does have x-intercept, that means y would have to be 0. So I put a 0 right here. And I'm going to solve and figure out what we got going on. So that means x squared plus 3. Well, I can just minus 3 then. So I have -3 equals x squared. And then I'd have to do the square root to get rid of the square here, which means this would have to be plus or minus. Whenever you do square roots on both sides, it could be positive or negative. But that means x equals the square root plus or minus of -3, which is imaginary. So this is true then. Since this is imaginary, that means there is no x-intercept here. So this is true. This is true. Which, that's like the graph I've drawn over here a while ago. It could be something like this right here. It has no x-intercept. Okay. All right. Let's go to number 4. Our number 4, it says determine whether the statement is true or false. The graph of this one has 2 x-intercepts. All right, well, let's find that one out. We got y equals x squared minus 10. Now, to have an x-intercept, that means y would have to be 0. So if I put a 0 here for y, then I need to solve this. Let's figure out what's going on here. So I can just add 10 to both sides. That means I have 10 equals x squared. This goes away. And then I can take the square root of both sides, which cancels my square. But when I do that, this could be positive or negative. So I have plus or minus radical 10, which is true then. I do have 2 x-intercepts. I got positive radical 10 and I have negative radical 10. So yes, this is true. This is true. It has 2 x-intercepts. I guess it's C right there. It is true. That's the only one that says true. Okay. What about number 5? Determine whether this is true or false. The distance between these points is 3. All right. Now, number 5 here, we got the distance formula. All right, the distance formula is this right here. The square root of x2 minus x1 squared plus y2 minus y1 squared. And it's a square root of all that. Okay, now I could take the time to explain what this formula means, but that might be counterproductive, so I won't do all that. But this is the distance formula. Now what these numbers mean is when you have 2 points, you got an x value from the second point and you have an x value from the first point. And the same thing on y. You got a y value from the second point and a y value from the first point. And you just plug them in this formula. So we're going to do that on this problem here, number 5. Number 5, we have these 2 points, 0, 0, 0, 0, 3, 3. Okay. Now, what is the distance between those? This says it's 3. Is that true? All right, so here's what we're going to do. This one here, we're going to call this point 1 since it's first, and we'll call this one point 2 since it's second. Okay. So this is my x right here in point 1, and this is my y in point 1. And then over here, that's my x in point 2, and this is my x or my y in point 2. And I just put those values in this formula right there. Okay, so that means my distance then is going to be the square root. All right, my x in point 2 right there, 3, minus my x in point 1 right there, 0, and that's squared. Plus, over here my y in point 2, all right, that's 3, minus my y in point 1, well, that's also 0, and that's squared. So there's your numbers put in the formula. Okay, now, what you can do is you could type all this in, but not the radical. You don't type the radical, so I'm going to leave my radical, but I'm going to type all this right here in. Okay, so I get my calculator here. All right, I'm going to have 3 minus 0 squared plus 3 minus 0 again squared, and it comes up to 18. So the distance equals the radical 18. And then we type that in. Well, that's not a perfect square, so that means we're going to have to simplify it. So that's going to be 2 times 9. 2 don't go into 9, but 9 is 3 times 3. Okay, and then look here. I got a pair. That's going to send a 3 out, but this 2 is stuck because he doesn't have a partner. So here's what my distance actually is right here. Oh, got it off the screen. I'm sorry. So I broke this down, and I got a pair of 3s. So that sends a 3 out, but this 2 is stuck. Okay, so 3 radical 2. That's what the distance is. So this is false. It said the distance was 3, but it's actually 3 radical 2. So this is false. The distance is actually 3 radical 2. Okay, we'll do another one. Number 5. Okay. So for number 5 here, for the point P here and point Q, find the distance and the midpoint. All right, now the midpoint, when you have 2 points, and you have this line, all right, the distance we just talked about between these 2 points. The midpoint is the point in the middle here. And basically all you do is you got an x value here and you got an x value there. All right, so all you do is you take these 2 x values, you add them together and divide by 2, and that'll put you in the middle of it. And then the same thing goes for your y's. You got this y value, you got that y value right here. So to find in the middle there, you just add them together and divide by 2. And that'll put you there where the midpoint is. So in other words, you have this formula here. This is your midpoint formula. You take your x's and you add them together and divide by 2. And you take your y's, you add them together and divide by 2. Basically, it's like finding the average. You take the 2 values, you add them, divide by 2. That's finding the average. And you do the same thing for the y's. That's your midpoint formula. Okay? So on this one here now, we've got P, which is -9, -10, and we've got Q, which is -4 and -5. We want to find the distance and the midpoint. You see our answers over here. Okay, well, let's do them. All right, so for the distance formula, I'll write it down again. Okay, there's my distance formula again. All right, so now again, we're going to call this one point 1 since it's first, and we'll call this one over here point 2. It doesn't matter which one's point 1, which one's point 2, just so you get it straight and then follow through with it. So my x in point 2 over here is -4. My x in point 1 is right there, -9. All right, well, I'm going to have to do a -9 like this in parentheses, like that. Okay, my y in point 2, right there, -5, minus my y in point 1. All right, that's a -10. And all this is in a radical. Okay, that's my distance. Okay, now, like I said, I'm going to leave this radical, and I'm just going to type all this under here, type that in. All right, so let's get this thing going. All right, I got -4 minus and a -9. Don't forget this second parenthesis here. And then it's squared. Okay, and then plus, and then I got -5 minus, and then in parentheses I got -10, double parenthesis there, and it's squared. Okay, 50. All right, so the distance is radical 50. Now this is not a perfect square, so I'm gonna have to break it down. So divide by 2, well, that's 25. 25 does not divide by 2, but 25 is 5 times 5. So you break them down like this, and then you look see what you have pairs of. All right, well, I have a pair of 5s, so that's going to send out a 5, but this 2 is stuck. All right, so it's going to be 5 radical 2. 5 radical 2. The 2 5s pair up, that sends a 5 out. This 2 is stuck in the radical because he doesn't have a partner. So there's my answer for the distance. We got that, 5 radical 2. Now the midpoint. All right, let's just do the midpoint over here on this side. Okay, we'll get that over a little bit more. All right, so midpoint, it's right here. I'm going to add my x's together, divide by 2, and then I'm going to add my y's together and divide by 2. So that means on my x's here, all right, so I've got -9 plus -4. I'm going to divide it by 2. And then I take my y's, which is -10 plus -5, and I'm going to divide that by 2. Okay? All right, so Let's punch this in here, -9 plus -4. Now you have to hit equals, and then you got to divide by 2, which comes up decimal, and they don't like decimals, so I'm going to change it to a fraction. And there you go, it's -13/2. They do not want decimals on the program. Now I'm going to do this one. -10 plus -5, hit equals, and then divide by 2. And it's decimal, so you can change to a fraction, -15/2. And this is my midpoint. And let's see here, make sure we're right here. -13/2, -15/2. Yeah, we got it. All right, good deal. I like to get them right. So we're doing the same thing here. All right, I'll go through this one just for the basic sense of, repetition. All right, so I've got P is 8, -20. And then I've got Q, which is 13 and -17. All right, so my distance formula, all right, I'm not going to write it out again. I'm going to go straight into it. So it's going to be 13 minus 8, that's squared, plus -17 minus -20, and then that's squared. Okay. All right, so now again, all this under the radical we can punch in, but not the radical. So my distance is going to be the radical of, now I type all that in, so all right, let's get over here. We can 13 minus 8 squared plus -17 minus -20, and that's squared. All right, looks like 34. Okay, now that's not a perfect square, so I see if it breaks down. So 34 is 2 times 17, circle the 2, and 17, gosh, it won't break down either. So I don't have any pairs coming out, so it's just radical 34. And you can see right there, that's what we had, radical 34. Okay, now what about my midpoint? All right, we'll do midpoint over here on the side. All right, so for midpoint, I'm going to add my x's together. So I've got 8 plus 13 divided by 2. And then I add my y's together. -20 plus -17 divided by 2. And that would be my midpoint. Okay, 8 plus 13 is 21. So it's going to be 21 divided by 2, which is going to stay 21/2. And then -20 plus -17, that's -37 divided by 2. If these are odd, they won't divide. They only divide if they're even. So, yeah, we got it right. We got it right there. Okay. Now, number 8 down here. There's a couple like this. Is this triangle with these vertices, is it a right triangle? Okay. Now, what we're going to have to do is we're going to have to use the Pythagorean theorem. So the Pythagorean theorem, a squared plus b squared equals c squared. This is my Pythagorean theorem. All right, so we have these vertices. We got A, which is 7, 2. Now this is a different A, B, and C here. This is the point A. We got point B, which is 0, 6. And we have point C, which is -7, -4. Okay. Now, you could graph those to get a visual of them. I'll graph them. We got 1, 2, 3, 4, 5, 6, 7, 1, 2 right here. We've got 0. I'm not going over any. I'm going up 1, 2, 3, 4, 5, 6. Okay, this was A. This is B. And then C is -7. 1, 2, 3, 4, 5, 6, 7. And -4, 1, 2, 3, 4, which would be like right here. So we've got this triangle right there. Now it really doesn't look like it's a right triangle to me, but you can't go by looks because my graphing could be off just a little bit. But what I need to do is I need to find these distances. See, here's my A, B, and C, these distances. Okay, so here's my C. So I need to find AB, the distance from A to B. I need to find the distance from B to C, and then I need to find the distance from C to A. All right, so I got to find AB, I got to find BC, and I got to find AC. So I have to find all three of these by doing the distance formula. So AB is going to be, I use these 2 points, so it's going to be, all right, it's going to be 0 minus 7 squared plus 6 minus 2 squared. Okay, that'd be the distance of AB. Now, leave my radical here, and so I'm going to have, let's see, this is going to be, all right, here we go. 0 minus 7 squared plus 6 minus 2 squared, and that's 65. All right, now, what might be better, instead of breaking them down, we'll just leave them like this on this problem here. Let's go ahead and leave them like that because I've got 3 of them to do. So I'm not even going to try to break them down, so leave them that way. Now on BC, all right, so for BC, I'm going to use these 2 points right here, okay? So I'm going to do negative 7 minus 0 squared plus negative 4 minus 6 squared. Okay, which is going to be, I don't have a whole lot of room here. I kind of wrote this too close. That's going to be, let's see if I can do that in my head, 49 and 149. Okay, and then AC, all right, we'll do AC. For AC, I've got to use these 2. All right, so I'm going to do negative 7 minus 7 squared plus negative 4 minus 2 squared. All right, so I'm going to do negative 7 minus 7, negative 4 minus 2. Okay, this is going to be, I think, 232. Let me do it in, let me make sure. I don't want to make a mistake here. Negative 7 minus 7 squared plus negative 4 minus 2 squared. 232, okay. All right, so I have these 3 right here. These are my 3 distances. All right, I'm going to use the Pythagorean theorem to determine if that's a right triangle or not. So if this is a right triangle, this one right here has to be the C because he's the biggest. So that has to be the C. So these are A and B. So that means radical 65 squared plus radical 149 squared should equal radical 232 squared. And when I square this, the square and the radical cancel off. So it's just 65 plus 149 equals 232. So that's why we just left them like that, because it's just actually a little bit easier to do that instead of simplifying them. And now do these 2 add up to, I think when I add these together, it's going to be a 14, it's going to be a 214, I think. Yeah. They're not equal. So no, it's not right. It's not a right triangle. Okay. And that's what it said over here. That's no. All right. Here's another one. Is this one a right triangle? We'll go through that one maybe a little quicker. Okay. All right, so I have A, which is 7, 2. I've got B, which is 0, 6. And I've got C, which is negative 8, negative 8. All right, so I need to find AB, I need to find AC, I need to find BC. Okay, so AB are these 2. So that's going to be the square root of 0 minus 7 squared plus 6 minus 2. All right, so I'm doing these 2 for AB. So it's going to be 49 plus 16, 65, I think. right, and I'm going to leave it like that. Let me check it again. There's 4, 16, 49, 65. Okay, now AC, I'm going to do these two. All right, so I'm going to do -8 minus 7. -8 minus 2. All right, this is going to be 225. This is going to be 325. All right, so there's my first two. Now BC down here, I'm going to use these two. All right, so it's going to be BC, I'm going to go -8 minus 0. And I'm going -8 minus 6. -8. All right. So it's going to be 196 and 64, 260. Okay, I did these in my head, but now, if this is a right triangle, this one here, this has got to be C because he's the biggest. See, C is always the biggest. All right, so that means these two would be my A and B. So radical 65 squared plus radical 260 squared should equal radical 325 squared. All right, the squares and square roots cancel, so 65 plus 260 will equal 325. And if I add these together, that's 325 equals 325. And yes, it's a right triangle. All right. And that's what it says, yes. Okay. Now we've got 3 questions in a row here, 10, 11, and 12. Are these collinear? All right, now to figure out if they're collinear, what we're going to do is we're just going to check the slope. This is the slope formula. Slope is m. That's going to be the y from point 2 minus the y from point 1 divided by the x from point 2 minus the x from point 1. And so these are the same thing. You got your points. So like on number 10, okay, we've got 0, -5. We've got -3, -8. We've got 2, -3. Okay, now again, you could just graph these. Let's see what the graph looks like. 0, I'm not going over any, I'm going down 1, 2, 3, 4, 5. There's 0, 5, -5. And then -3, 1, 2, 3, and then -8 would put me right there. And then 2, and then -3 would put me right there. And they do kind of look like they're collinear, don't they? Yeah, they do. So, but you can't go by looks. So you have, what we're going to do is we're going to take these first two, we're going to find the slope between these first two. So my y in point 2 here would be a -8 minus my y in point 1, well, that's -5. And then my x in point 2 is -3 minus my x in point 1 is 0. So this is going to give me -8 minus -5 is -3. And then -3 minus 0 is -3. And this comes out to be 1. So my slope for these two is 1. Okay, now I'm going to do the slope of these two. All right, so let's get a visual here. 0, -5 was this one. -3, -8 was this one. So the slope here is 1. Now I'm going to do these two here. And if I get 1 for that, that means they're all collinear. Actually, I'm going to do these 2 points, I think, is what I underlined. So let's do the slope for that. Okay, so, all right, so I've got my y in point 2. This will be -3 now, minus my y in point 1, which is -8. Then my x in point 2 is 2, minus x in point 1, which is -3. And then -3 minus -8 would be 5. And then 2 minus -3 is 5, and 5 over 5 is 1. And look here, I got the same slope, which means, yes, they are collinear. They're all in a straight line. Okay, so the graph looked like they were, but you can't go by the graph really. So we're not going to do the graph in this next one. Okay. So on this next one, we got 0, -6. We got -3, -12. We've got 2, -2. So all you're going to do is you're going to do these two, find the slope of them, and then you're going to do those two, find the slope of them, and see if they're the same. And if they're the same, they're collinear. So for these two, I'm going to do the y in point 2 minus -12 minus -6 over -3 minus 0. So -12 minus -6 is -6. -3 minus 0 is -3, and that simplifies to 2. So for these two, I got a 2. That's my slope there. Now, what about these two? So I'm going to do it again. Okay, so my y in point 2 is -2, minus my y here in point 1 is -12. Now, when I'm using these two now, this is point 1 now for these two, because he's first of these two. It was 0.2 when I did these two because it was the second of these two. So I'm switching them up, going in order. So -2 minus -12. And on the bottom, I got 2 minus -3. All right, so -2 minus -12 would be 10. And then 2 minus -3 would be 5. And that simplifies to 2. And lo and behold, they're the same slope. So yes, they are collinear. All right. Now we've got another one here, number 12. I'm not going to do it, but if you notice on it, it says no. So here's the points. You can try this one yourself. These are not collinear. All right. Okay, now we get to number 13 here, and I'm going to have to do these on the computer here. So we'll just slide over here and look at the computer. All right. So on this, it says give the order pairs of their solutions and graph the equation. So right here, we've got 3y equals 5x minus 15. All right, now if x is 0, what would y be? So if I put 0 in there, 5 times 0 would be 0. So that means 3y would equal -15. So you just do a little solving. That means y would have to be -5. So I'm going to put a -5 in there. Okay, check my answer, and we're good. Okay, now what if I put 0 in for y? This is when you have equations like this, it's real easy just to find your x and y intercepts. So we just found the y-intercept. Now we're going to find the x-intercept. I'm going to put 0 in for y. So if I put 0 here for y, I got 3 times 0 is 0. So I've got 0 equals 5x minus 15. So I'll add 15 and solve that. I think you guys can solve it. It comes out to be 3, and that's right. All right, so now we're going to graph this. So here's what I want you to see how to graph this. I'm going to take 0, -5 and plot it. And then I'm going to take 3, 0 and I'm going to plot it. So if I click on the graph here, I've got to tell it right here that I'm drawing a line. So I click on that. And now all I do is see my little axes that come on the screen there when I move around, okay? After I tell it I'm graphing a line, I just plot these two. So 0, -5, I'm not going over any, I'm going down 5, that's right there. All right, then I go up. Now see, I've got my line started. I've got to go to 3, 0, which means I'm going over 3, and I'm not going up or down any. So there's that point, and so it draws my line. I check my answer, and I'm good. Okay. That's number 13. Let's go to 14. Okay. These last three. Oh, did I get timed out? Okay, I'm good. All right, so it wants me to find my y-intercept here. I'm putting 0 in for x. So if I put 0 here for x, this will go away. All right, this will go away. So I have 5y equals 15, which means y would have to be 3. Okay, you're just solving those. You guys can do that. It's same stuff from chapter 1. Now I'm going to find the x-intercept when y is 0. So I'm going to put 0 for y right here. So this will go away. All right, so I have 3x equals 15, which means x have to be 5. And there you go, okay? And now we're going to graph them, so we do the same thing. You just click the graph. All right, then this little options come on here. You got to tell what graph you're doing. Well, we're doing a line on this one. And then, see my axes are on here. I'm going to do 0, 3, which means I'm not going over any. I'm going up 3, which is right here. And then I got 5, 0, which means I go over 5, and I'm not going up or down any. There you go, and we're good. Okay. All right, then we've got this last one, number 15. And it's going to make a parabola, this last one does. See, it's got, hold on. It's already done. Okay, so see it has x squared in it, which means it's going to make a parabola. So I put these values in. So if I put -2 in for x, -2 squared would be 4. And then 4 plus 5 would be 9. So this would be 9. Okay, now 0. You got to do all 3 of these first. So 0, if I put 0 in, 0 squared, see right here? 0 squared would be 0, plus 5 would be 5. And then 2, if I put 2 in, 2 squared is 4. 4 plus 5 would be 9. All right, so there's my values. I'm going to check my answer down here. Okay. All right, we're good. All right. Now we got to graph them. Okay. So I'm going to click the graph just like before. This time it's going to make a parabola like this because it's x squared. Anytime you have x squared, it makes a parabola. So I select this choice. Okay, and same thing. I just plot those points. So I go -2, which means I go back 2, and then I go up to 9, which is right there. Okay, then I got to do 0, 5, which means I go over none, and I go up 5, which is right there. Okay, now it looks like a line, but now when I do this next point, it's going to turn into a parabola. So 2, 9, see it? 2, 9 is right there. There's my 3 points. Now, if you noticed afterwards that, oh man, I've graphed this on the wrong spot, you can click this and pull it down if you need to. Well, it ain't working. There you go. You can pull it down if you've got it in the wrong spot. But we were right, so I'm going to put it back. There it goes. And then check your answer. Okay, so that's how you navigate through that. And that's the homework from this one. So we're done here. That's rectangular coordinates in section 2.1. If you have any questions, just give me a buzz and I'll help you all I can. Have a great day.